All right, so time to start. So now we're going to be talking about Rust. Basically, this class is just for Rust, right? Trying to make you understand what Rust is and to give you enough information to begin your own development in Rust. So, first things to know about Rust, I'm going to be using this this online editor since we are just starting up. Okay, this way the last classes we had. Okay, I think I'll just clear this so we can just start from the beginning. Right. Better still. And just create a new one. Sorry, please. I'm coming. I just got this out. Okay. Okay, so I'll just use this online editor to kind of explain the basics, first of all, before we start diving deep into using our VS Code to write. So one of the first things to know is that just like every other programming language, Rust has comments, right? So until you define a comment in Rust, you use this double backslash, right? Or forward slash. So use this just like in JavaScript or any other language, Solidity and the likes. So this is how you define a comment, right, in Rust. So you can say this is a comment. Now, when you do this now, the compiler, right, will have nothing to do with this. It's just going to assume it's nothing relating to what it needs to do. So a bit of background before I jump into all of the code. So Rust is a statically typed language. And what I mean by statically typed language is that what I mean by that is that it allows you to always specify the type of your variables and your functions and whatever data type you are using before the compiler can execute it. So that means because we are mentioning the compiler, means that Rust is a compiled programming language, right? So now, because of that, Rust is a compiled language. So that's another thing to know. So Rust is a compiled language, right? So that means that it expects you to always specify the data type before runtime. So it can actually infer what data type it is at runtime. So that means that when you define your code right now, let's say I want to write a variable, for instance, and I want to say my name, I need to specify if it's a string type or not, right? So basically now this here is the difference between Rust and most programming languages. Now, programming languages like Python, for instance, now do not expect you to specify the type at all. Now, what do I mean by doesn't expect you to specify the type? You can have something like this, name equal to in Python, right? And in JavaScript, for instance, for those of us that might be familiar with JavaScript, you can have something like const name equal to, right? But in TypeScript now, because it's TypeScript and expect you to have typing, just like we have in Rust, you need to specify the type. You can, like this, and it works also. So the idea is that whenever you define variables or your functions in Rust, it needs you to always type it. So we say that Rust is statically typed. So it's a compiled language. Rust is statically typed. So it needs to know what type of variables or functions or any data type it's going to be making use of or is going to be using at compilation. So because of that, it's a compiled language just like other low-level languages like C, C++ in its own use, and it is also compiled. And that thing about Rust is that Rust is memory efficient. So those are the properties though. So Rust is also memory efficient. It's very memory efficient in the sense that because it doesn't allow you to waste memory. Now, let me give an instance now. If you have a variable like this, let's say, let me just define something simply like this. Let's say I have this function, right? And I say, now this is a very simple text, right? And let's say I move this into my main function. right? But I do not make use of it. So I do something like this. It's going to give me this warning, first of all. There's an unused variable. Now, even though there's no error, this is just a warning, right? It's not an error. But you can see that it's telling me that I need to use whatever variable I define. So because it expects me that it expects me to use, or whenever I declare a variable, in this case, I'm already allocating this to memory, right? That means there's a certain space in memory that this is going to use. If I compile this now, or I convert it to an executable now, instead of taking, let's say this takes just an example now, let's say this takes 108 bytes of space. Because of this memory, that this sort of this string that I've already assigned to this variable that I'm not making use of, it might eventually become like, let's say this is a string, so that means it's going to take like 32 bytes, right? Just 32 bytes. So now at the end of the day, this program is going to combine, the total size of this program is going to be, it's going to be 32 plus 108, right? Which at the beginning of it is going to be 140 now, right? 140 bytes, which at the beginning should just be 108 if this was not used. So now, as small as this memory size may be, because it's just 32 bytes, just as an instance, right? You have added more to the size of the program, which is not supposed to be, because at the end of the day, you want it to be as small as possible. You want your program to be as small as possible. So now, because of that, Rust will always make you know that, okay, this variable is unused. You need to actually use it or remove it. So it tells me variables that I don't use. Now, this is very efficient when you are dealing with large databases, because you might declare a variable somewhere and not make use of it. Rust will actually let you know that this variable is not used, right? Like it will tell you to say that, okay, if you don't want to use it, on previously with an underscore. In this case, now, if I use an underscore, the error will leave. But in this case now, the underscore simply tells us that optimize this code so that even if I'm not using it, you don't need to actually include it in the build release of this code. Now, that's just basically what it does. So if I don't indicate this and I do this now, so if I'm adding an underscore, it's because it's intentional, probably because there's a reason for me, or I want to use it in a future release, right? Now, all of these things are important because that is one of the ways that Rust manages your memory for you. It checks. There are other ways it does that. There are other ways of, giving you suggestions on do it like this, don't do it like this. For instance, you can't have a while loop that you don't clean. You can't have like switch loops, whatever kind of loops that you don't clean up after. You can't have memory that is dangling. You can't have all of those things. So Rust helps you to efficiently manage it. So in this case, now if I remove that memory space now, this new size now becomes 108 bytes. That means I've saved 32 bytes from that space. Now, in this case now, this might just look small, like I said, but when it comes to large code bases, imagine how much you have removed and stripped from the code by just removing unused memory, 1, removing dangling memory, 2, because Rust will force you to write good code. That's another thing. So that way, it makes your code very memory efficient. So, and by being memory efficient, your code will perform faster. Your code becomes optimized and perform faster. So it is efficient in terms of handling memory. It is safe. Another thing is Rust is safe. You can write bad code, right? You can write bad code, but it's not common, right? It's not common for you to write bad code with Rust because you always have to maintain. So Rust has a very strict rules that it follows. So now I think that's the first thing I should know. Rust is very strict. That's one thing about Rust. It's very, very strict. So these are properties of Rust that you need to know. I think very important to point out. Yeah. So okay, somebody wants to. So these are like properties of Rust you need to know at the beginning because all of these things are important here. Rust will do all of this. So if I run this code again, I haven't removed the unused variable. You can see that there's no error. Everything works well. So that's the idea. So in this case now, it helps you to write good code. It's a very strict programming language. It is very, very strict. But being strict means that it takes a longer time to make sure that everything works well. So the beauty of it is that once you write it and it works well, even if it's just once, you can be sure that your code is almost perfect. Like most Rust programmers will say, they'll just be like, write your code and go to sleep because we are sure that nothing will break. And that is why most companies are moving into Rust. Even big company like Google, they move into Rust. Because let me give an instance now. Recently, Google has begun to optimize their Android operating system using Rust. And there's a very good reason for that. Android is very, how do I use this? What's the word to use now? Android is very power hungry, right? Android takes a lot of power, very, very much. And that is because there's a lot of memory leak somewhere. But because the code base is huge, it is almost impossible for you to find it. And that's the problem about those kind of code bases. For instance, you are writing a program like Java, you will definitely have a lot of circular dependencies somewhere, or you have a lot of memory that is not being used. Now, because there isn't a virtual machine, of course, the VM will optimize as much as possible for you. But that doesn't mean there is not unused code somewhere. Because at the end of the day, even though the VM is optimizing the code for you, there are a lot of codes that you've not used somewhere, or there are a lot of ways you could have written the code better that programming language will not tell you, because that is how it is built. But it's built to be efficient in its own way. But because Rust is that strict, Rust will tell you that this is how it should be done for you to be better. So now, recently now, Google developers, that's the Android developers, have begun to port most of their languages that are written with C++, right, into Rust. And they've seen significant improvements. So that means that from Android 15, Android 14, basically, that just came out recently, you will have better power efficiency for Android phones. And that is a good thing. That's a good plus. That means it can even perform better than most other products out there. And that is one thing that is one example Rust has given, another edge to itself over other programming languages, because now Google is ready to adopt it almost fully into the Android Android space, because that way they can imagine them optimizing the entire Android operating system. It gives them better new customers because people want that. Then they can become more efficient. It's more money for them. So all of these things are reasons why Rust is just growing in popularity. Other programming languages, other companies are using Rust too, like Microsoft too. They're adopting Rust since past 3 years, using it to convert their whole operating system from C++ natively to Rust. There's a reason for that. So all of these things is just to avoid, to prevent the bad codes that have been written over the years that people keep building on. Because when you write with Rust now, you're actually writing from scratch. You have people that are very experienced. So there's a lot of this advantage that it gives to you, right? Even as a beginner, if you actually follow the errors that Rust gives to you, because another thing about Rust is that it gives you good error messages, like very verbose messages. Like very, very verbose messages. It gives you a lot of them. So you have a lot of that verbosity that Rust will give to you. So that's the first thing these are the things you need to know about Rust. So going forward, if you understand that Rust does all of these things, you won't get frustrated when you are writing your code and then you see errors and you're like, what is this? This is annoying. I don't get this type of error in other languages. Of course, it's normal to get frustrated at it at first, but if you understand the basics, you hardly will not get angry or feel bad about the kind of errors it gives to you and the warnings too. It's just to help you do the right thing and write better codes. So that is very important. So now let's go back to some of the examples we have here. So we've talked about comments, and from there I've translated into functions a bit, right? Because now let's talk about functions. So in this code now, I've written this function. If you're familiar with other programming languages, let me start from there. Let me use JavaScript because it's a very popular one, and Python. Let me just use those two. So you have JavaScript where you have something like function, right? So in this case, if I want to write the same thing as JavaScript function, this is what I'm going to do. So the same syntax you have in JavaScript or in Solidity, if you're familiar with that, the same syntax is basically what you have, right? You just have your function keyword, right? You have the main function. Now, the main function in Rust is the entry point. So this is the entry point to the main, is the entry point to your Rust program. So in this case now, is the entry point to your Rust program. So in this case, when you have something like this, you have the main program like this. It's simply the entry point, right? So in this case now, whatever you are working with, this is the first function that will be run or that will be run in your code. Now, if you're familiar with programs like Java, right, or C++ or C, basically, this is how it happens. You also see that this main is there, right? The same way you have this main in other languages like like Java, like I talked about, all of those languages maintain this same familiarity. So in main, for instance, like this, you can see that this is always there in almost every Rust programming languages program you will come in contact with, or every Rust code you will see. There will always be a main like this inside that code. And the reason for this main is so that you can you are just telling the compiler that, okay, this is where I want to start executing this program from, right? So whatever is inside this is what should be done. So let me give an instance. Let's say I have another function here called add, right? And inside this add now, I want to have like this. And I do something like 5. This is a perfectly valid function, right? Now, this is supposed to return, let me say, before that, let me just print line addition function, right? So in this case, let me take it to number so it can be more reasonable. So in this case now, this is an addition function, right? This is valid. This is totally valid. Now, but even though I have this function here, if I don't use it in this main, right, it's not going to take effect. Now, if I run this code now, I'll still see what's this line being printed for me. Yeah. Okay. Let me do something like this. Num1 plus num2. You can see the same error, the same unused variable again. Now, imagine if I have this function in my code and I'm not using it also, right? Rust will point it out to me because it's taking space. And so I don't want that. So then Rust will point it out that I can remove it or make use of it. So there are ways, if you've handled large code bases before, you know that this is common. Like, it's common for you to have functions that you don't use. You just define it and then at the end of the day, you don't use it. It's very common. So Rust helps you to not do something like that. So that's another way it helps you to keep your code optimized, more efficient, and as small as possible. So I'm now deciding to use those variables, right? So if I rerun this function now on this code, you can see that it's telling me that add is never used, right? And the result of the program is what? This is a simple text. Now, it simply means that even though I'm using this print line here, which I'm still going to talk about, it's not being reflected in this code at all. This is the only thing that is being printed, even though I have to print line. And this print line simply means print to the console or print to the terminal. But in this case now, nothing is being printed on this line. That's because I'm not using the add function anywhere. I'm simply making use of this main function, and that is it, right? So in this case, as beautiful as it is and as good as Rust is, you need to know that all of these things are ways Rust handles memory for you. The add is not being used because it's not being added into this main function. But the moment I do this, let's say I do 4,3 like this, I do something like this, and I include it in my main function, and I run this code, I won't see the warning again. That's the first thing. And then I can see this print line in the add function, right? So now, using this that I've written, now let's talk about the main. Sorry, I hope this is clear for everyone on the call. Am I going too fast? If it's not clear, please ask your questions so we can go back. That's why the live call, right? So I hope it is clear enough. Yeah, I'm still coming there. I've not already gone there yet. So I'll talk about this whole function. I'll still explain, right? So let me just like hide it like this. So I'll talk about what the U8 is now. So now let's talk about functions, right? I was just using that to point out something to you. So how do you define functions? The syntax for functions in Rust is you have the fn keyword. Now you have this first. Let's define your fn as the keyword. Now the fn in this case here, like this, means that you are tagging this as a function, right? So this is a function. This fn simply means it is a function. So whatever comes after it is the identifier for that function, which means you are giving the function a name. So say for instance, I say, get name. For instance, get name in this case is the name of the function. So this is the identifier for the function. This is the name I'm giving to the function, right? So I add the parentheses, just like in all other programming languages, many other programming languages. Then the parentheses is just so that if I have parameters, right, that I want to use within this function, I can add it into this parentheses. Then if I don't have any of it, I need to specify the return type if I have a return type, but that is optional. So that means if I have a return type, I have to use an arrow like this. If you're familiar with JavaScript arrow functions, this is very much settled with you. But if you are not, still just understand this. You need to use the arrow like this. You need to use your dash and the the greater than triangle or the right arrow on your keyboard like this. So you're simply saying that I want to return a so type. So in this case now, I need to specify the type I'm returning, right? If I want to return a type, but not all functions return a type. For instance, look at this main function. It's not returning any type. Actually, it is returning, but don't worry, let's not go there. It's not returning any type in this case, right? So, but this is returning a type. So now you can look at it and say, okay, so I have two functions. So I can decide to either return a type or not return a type. But if I'm returning a type, I need to specify the type that I am returning. Then I have the curly brackets like this, opening and closing curly brackets. Then inside the curly bracket, I have the body of my function. So this is the structure of a function, right? So you can have the function keyword that says that this is a function, the identifier for the function, the optional argument or parameters rather that you want to use for the function, optional return type, and the body of the function. So now using this analogy, now let's try to explain this. Now, this add function now simply says that this fn says is a function. This add is the name of the function. This num1 and this one up to this comma here simply says that this is the first parameter passed to the add function, and the num2 simply says this is the second parameter passed to the function, right? So in this case now, it simply means that this function is taking two parameters, right? So whenever I'm using this function anywhere, just like I did here, I'm adding two arguments to it. That's the 4 and the 3. So I passed in these two arguments, which is 4 and 3. And that is because I have two slots for these parameters to be passed here. And then I'm returning the U8, which is the data type I want to return. Now, I'm coming back to explaining what U8 is, right? So I'm returning this data type. This data type I'm returning means U8, right? In this case, it just simply means an unsigned integer. So what does this mean now? It means that whatever this function must return, like I said, if you use the arrow function, you're simply saying that return something for me. Whatever I'm returning with in this function called add, right, is an integer. That's what I'm saying here. Return an integer. But first, you can see that the parameters also are taking integer types, right? U8 here, U8 here. Then I'm returning that type here. So now, before I proceed here, let's talk a bit about the integer data types. Right. Let's go back to the reference we are trying to make use of, which is this. Right. But then you can see now, let's talk about the integer data type. But first of all, let's try to understand this function, right? Because this is the function keyword, the name, the parameters of the function here, right? Then the return type of that function. Then the body of the function can come inside of it. So now let's talk a bit about integers. So when we talk about integers, this will actually make a bit more sense because you need to build on the knowledge you get little by little by little. And I think one thing I need to point out is that for Rust, you need to know that Rust is not hard, right? But if you can understand the basic syntax, so I'm going to dwell a bit more on the basic syntax. So a lot of talking much more about it. So if you can do or dwell more on the basic syntax for Rust, right, and you understand it, it will be very easy to move into the more advanced parts. But you need to do a lot of more practice also for you to get familiar with it before diving into the advanced parts. I think that is just good advice also. So, all right, now that we've done all of this, right, let's talk about the integer types, the basic data types. So let me mention the basic data types first of all. Let me just give so let's talk about data types. So for the first data type, I'll talk about the basic data type, right? So yes. So before I proceed, any question about the function? I know I said I'll talk about the U8, or any other question about any other thing we've talked about so far? Anything at all? Okay. All right. No question. That's fine. Okay. So no question then. So that means we are good. All right. So now, since there are no questions, let's go to data types, right? So for data types, every language, every programming language has data types. For the basic data type, you are familiar with it also, the integer types, the strings, the Boolean, right? The bytes, all of these are basic data types, right? We're used to. So basically, let's talk about this for now, but let's talk about integers. Integers are like the most common ones and the simplest, not simplest, but more like the simplest of them after Booleans. So now let's talk about integer types. For integer data types in Rust and in most other low-level languages, there are always two integer data types. Now, integer data types are of two types. And so please try to follow what I'm going to explain for integer types because it has a lot of things to talk about, to explain. Yeah, so it's usually that way. So for integer data types, we have two types. The first one is the unsigned data type and the signed data type, right? The unsigned and the signed. Now, what is the difference between the two? The unsigned data type now, the unsigned, right, are those integers, unsigned integers rather, not data type, unsigned integer and the signed integer. Now, the unsigned integers are those integers that basically, in the basic sense, do not have sign. That's the meaning. It means that it does not have a negative sign or cannot have a negative sign. So that means that any number that is positive, it basically means that any number that is positive is as an unsigned integer, right? In other languages like JavaScript, which are like high-level languages, Python and the likes, we don't consider whether unsigned or unsigned. Everything to us are numbers, integers. But when you deal with languages like Rust, like C, like C++, that actually specify that you need to actually, that compile languages, right? In this case, you need to specify the integer type because of a certain reason. And the reason is because the integer types have variance when it comes to memory. The size they handle in memory vary. So let's see what I mean by that. But for unsigned integer types, we have them range from. So for unsigned integer type, right, they vary. And what do I mean by they vary? So they range from negative, not negative, range from 0 rather to you. Okay, let me not use that one. So they range from 0 to like a very high number, and 9 number they range from is U256. Let me just specify it. Right, that's the number. That's where they range to. Now, the reason for this is that when I say the U8 now, for instance, so that means U8 in this case, just like I explained the other time, like I've already used inside this function now. U8 basically means 8 bits unsigned integer. That's the meaning. So that means, what do I mean by this now? It simply means that it starts from 0, right? Like I said, the unsigned integer range from 0 to a very large number. But in this case now, it range from 0 because I'm using U8 and it's an 8-bit integer. So it range from 0 to equal to from 0 to 2 raised to power 8, like this, minus 1, which means that it starts from 0 to 255, because 2 raised to power 8 is what? 256. Then minus 1 is 255. So that means 8 bits. When you have U8 like this, we are simply saying the maximum value this can take is 255 as the maximum value. So let's try to define something. If I do something like this now, inside this add main function, and I do, let me say I define a variable and I call it A, for instance, and I say it's a U8 type, and I say it is 256. Now, this is wrong, because the maximum character, the maximum number that U8 can take based on this calculation that we have here is what? 255. So it's starting, the list is 0, the maximum is 255. For U16, like this, which means it's a 16 bits unsigned integer, right? So it ranges from 0 to 2 raised to power 16. So in this case, that means it ranges from 0 to 65536, if I'm not wrong, minus 1. So that means this range from 0 to 65535, right? That's the meaning. So that means the highest number I can have for U16 is what? 16 equal to 65535. Once I have 65536, I have gone past the maximum number. So it's wrong already automatically. So now let's see that now. Let me try this. So if I run this now, remember that the U8, which is this, the maximum number it can take is what? 2 raised to power 255, right? Now let's try, and I added 256 here. Let's see if it's going to work now. If I run this, I'm going to get an error. Now you see this, it's telling me that, okay, let me first comment this out. So that's where the error is coming from, first of all. That's another way it helps us to keep our code safe. You can't write bad code. Now, two things. You can see this. It's telling me that unused variable, first of all. Now, the second thing is this. It says out of range for U8. Now, I was talking about the range here, right? I said it ranges from, okay, let me change this to ranges from 0 to 2 raised to power 88, which means 0 to 255. Now, because I'm using 256 here, it says the literal 256 does not fit into the type U8. Whose range is this? So based on what I explained here now. So you can see that the compiler is already telling you what the error is. Like I said, it's very verbose, right? Like I said the other time. It's very, it gives you very good error messages. And it's very verbose. That means it will tell you everything line by line, tell you where the line is, tell you where the error is, and probably ways to fix it. So this is already telling me that the literal 256, which is the string, the integer rather, that I'm using here, does not fit into the type of U8. So it means that this type of U8 is too small to contain this type, this literal, which is the integer 256. So what do I need to do there? I just need to reduce it to the size it can contain. So that way I can reduce it to 255 now. And if I reduce it to 255, even though I'm just removing 1 from it, it's going to work now. And you can see that there's no error. It's just telling me this warning that I didn't use the variable, but there's no error. Everything is working fine. So that is it. So that's the first thing about the U8. So when you see an unsigned integer 8, just know that it starts from 0. Unsigned integers always start from 0 because they cannot have a negative sign, right? Unsigned integers will start from 0 because they cannot have a negative sign. That is very important, like very important to have. So now, that aside, right, say we've explained that one, it makes a lot of sense. So is this clear to everybody before I proceed? Any questions so far? Maybe I need to backtrack a bit so I can know. Okay, no question. All right, cool. So now that means that unsigned integer starts from what? It starts from 0, range from 0 to the maximum number. So now in this case for U8, the maximum number is what? 255. For U16, the maximum number is 65535, right? So for U32, you can now do the calculation too. It's going to be U raised to power 2 raised to power this, something similar to this. So let's do it now. For U32, it's going to be a 32 bits unsigned integer automatically tells you that it's a 32-bit unsigned integer that ranges from 0 to 2 raised to the power 32 minus 1. So that means from 0 to whatever value it is. I don't have that one in my head. So that basically means you can do the calculation and see. So that means the U32 can only take the maximum number of whatever this gives to you at the end of the day. Right, so that is that. So now let's talk about the signed integers. So now, one thing to also know is that for the unsigned integers, we use the U to like talk about them, to explain them, right? To show that this is an unsigned integer. For signed integer, we use the I sign. So that's, you can say I like this. So I will show you what that means. So this unsigned integers means that it can take a sign, right? So it takes both negative and positive numbers. That's the meaning. So signed integers are the ones that allow you to have negative values and positive values. So it can go below 0, right? So now let's see that as an example now. So the first thing we need to see is, let's say, okay, so now let's look at the range, right? So it's signed integers means that from negative to positive, we've established that. So it ranges from any negative value, but it needs to have a size also. Now we've understood that when you have U8, U8 has a size from 0 to 255, right? U8 has a value from 0 to 255, which is very okay, right? But also, that is not the only thing. Even though U8 has a value from 0 to 255 now, I8, let's say we have I8 like this. I8 takes a sign. That means it takes negative and positive numbers. So it means that it can, don't forget that the maximum value this can take for U8 is what? 256, right? That's the maximum. So let me just point that out. Max of 256 size, or max size of 256. Now for I8 now, I8 being 8-bit also means that it can only take, the max size is what? 256 also. That means the maximum size of an 8-bit integer, whether signed or unsigned, is what? 256. That's the maximum size, 256. So now for I8 also, whether it takes in negative or positive, it can be more than 256. So now, because it takes a negative sign, that means we need to split the 256 into 2. We give half of it to the positive side, we give the other half to the negative side. So that means for I8 now, because it takes both negative and positive, what we need to do is to now start from the negative side, then take it to the positive side. So in this case, I8 is going to range from minus 2 raised to power 8 to 2 raised to power 8 minus 1. So in this case, it means it's going to range from, sorry, not 2 raised to power 8 now. It's going to range from 2 raised to power 4. Is it 2 raised to power 4? Let me check my calculator. Yeah, not 2 raised to power 4 now. It's going to range from 128, which is not 2 raised to power 8 now. Because, like I said, we are going to split it into 2, right? So it's no longer 2 raised to power 8 anymore, right? Now, it's now 128 in this case. So if you are doing that, it's going to be 2 raised to power, sorry, not 4, not 4. So let me see. It's going to be 2 raised to power 7. Yes, 7 in this case, because it's going to be 2 raised to power 8 minus 1, like this. But let me just put it at 3 raised to power 7, because now we are splitting it into 2. So it's going to be 3 raised to power 7 minus 1. Now the reason for this is because we are taking one byte out of it to expand it. So, but the easiest way to understand this is that we just take the 256 as the maximum, divide it into 2. So when we divide it into 2, we are going to get 256 divided by 2 is what? 128, right? So now what gives us 128 is 2 raised to power 7. That's like the easiest way to understand it. So we won't go into the details of why we remove one particular byte or one bit out of it and stuff like that. But the first thing we need to just understand is that it comes from minus 2 raised to power 7 to 2 raised to power 7, like this, minus 1. This is just it. So it simply means that it's going from -128 to 127. Yes, this is what we have. Now, if you add these two together, right, you are going to get to 56. I mean, taking the absolute value of these two, you are going to get to 56. The reason is because from 128 to 0 is going to give you 129. Then add 129 to 127, you are going to get 256. So now this is the maximum value you can get for an I8, and this is the minimum value you can get for I8. So it's still the same thing as what we have here, but the difference is that we are splitting it into two. We are giving half of it to the negative side, which is this, and we are giving the other half to the positive side, which is this. So that means you have from negative 128 to 127 for I8. You can do the same thing for I16 too. If you have I16 like this now, it ranges from 2 raised to the power 15 this time around to 2 raised to the power 15 this time around. And then the value is going to be divide 65536 by 2 again. You will get the value of this side, and you will get the other value of this side minus 1 if you divide it by 2. So that's basically what you will have. So that is that's the size difference for integers in Rust. So if I say that, okay, I'm using a U8 like this, it's just what I'm just saying is that the maximum value it can take, maximum value is 255, right? But if I change this to say I8, for instance, in this case, it simply means that the maximum value I can take is what? 127, no longer 255, because now it's an unsigned, is a signed integer type. So please, is this clear enough? Do I need to go over to explain again? Or it's very clear? You have explained it. Okay. All right. So I think clear enough. Please, if it's not clear, anybody, I think it's only you that is responding. If it's not clear, please indicate so that I can explain again. I know it can be confusing, right? The language has a lot of rules, yes, but still, it's once you understand it, it makes a lot of sense. So you need to understand these basics first. Once you do, you can then begin to talk about more complex details in our subsequent classes. So please, if it's not clear, please indicate so that we can proceed. Okay, so I assume it's clear. So then, since this is already established, so what we need to do now is, we already know that our integer types are of this. So let's talk about the Boolean data type. Boolean data type are just basically the actual true or false, right? Everybody knows this. Booleans are true or false. So that's the Boolean data type. That's what they are. They are basically true or false, just like you have another programming language. That's it. So if you're not familiar with any other programming language, the point is a Boolean takes in true or false. And integers, like I've explained, have two types in Rust, right? Unsigned and signed. Whether you are familiar with any language or not, this is the easiest way you can understand it, right? So because most high-level languages does not make you understand it like this. But in Rust, you need to know this. And in other low-level languages too, if you are deviating eventually, or probably you need to use them to C, C++, they have the same concept. So it's good to understand them, and then you can move from there. So that is that. So Boolean data type, just true or false. So whenever we have something like this, let is active, you can say bool equal to false. So it simply means that we can, whenever we mark it as bool, it means it's either taking true or false. You can't take any other thing. Of course, you can take 1 or 0 too, but you can't take any other thing. So it's better to just leave it as true or false, right? So I think that is important. So for Boolean, it is what? True or false. Now let's talk about strings a bit. Before we deviate to string, let's look at the resource we are using. So I'm just be talking out of my head now. Let's see. So we've talked about this. We've mentioned all the functions and the likes. So let's talk about the integers. We've mentioned integers. I've talked about the bit width. Yes, which exactly something like this. The bit width for this is this. You can see, and they have a size range. I don't know if they showed it here. Okay, they didn't. But that's basically the idea. So now But let's look at an example based on what I've shown already here, right? That you can't have this. Okay, I think I've shown that too. Okay, so since I've shown that, let's look at another one, variables, right? So let's talk about variables before coming to strings, because string is a complex data type too. It's a basic data type, but sometimes it can get tricky. But let me just talk about it. So now let's say we have the string data type. Now for string data type, it's a string is just a first thing to understand is that a string is a collection of bytes, or you can say it's an array of bytes. That's what a string is. So in order to talk about string, you need to know that a byte is just, you need to know what a byte is. So now to explain that, let me use this to better explain what a byte is. If they have byte, okay, now byte, when you talk about byte, you're talking about characters. I think that is easier to deal with. Let's see if you have good examples here that you can talk about. Okay, let's see. Yes, okay, so characters here. So in this case now, let's say you want to define a character or byte. Now, let's just move on for now. Come back to this byte and stuff in a later time, because it's important to know them, right? But let's not talk much into detail about them. It's a whole lot most times. Let's talk about variables for now. So I'll come back to strings when we need to use them, because we've not used strings at all here. I've only used integers and booleans, right? But it's good to just know that the way you define string, basically in Rust, as an example, is first thing to know about string is that it's a collection of bytes or arrays, an array of bytes. And what that means is a collection of characters. Let's call them characters here. They are not bytes. In this case, they're characters. We call them bytes in other languages too. So it's a collection of characters or an array of characters. Now, characters in the sense that this is a character, in this case is A. A is a character, like is a character. A is just a character. B is a character too, right? C is a character. D is a character. So, but like I said, let's talk about the variables first. I'll come back to the string data type. So now let's talk about variables first of all. Now, I've shown you guys variable once, which is an example of all of this. Right. Well, better still, let's talk about the string before we move, so that we can complete the data type completely like this. Then we talk about the variable data types and the variables in general. Okay, about Lua, your question. Yeah. Do you have a question? Please go ahead. Question? I can't hear you if you're speaking. Oh yeah. I use the ampersand string. Yes. That is a string. So that's I'll still show that. I just wanted to move on, but let me just come back to it. So now is a collection of, to talk about strings, I said a string is a collection of characters, right? Or you can look at it like an array of characters. Better still, take it as an array of characters, since we are dealing with programming here. So it's a collection or an array of characters. So, and the character in this case now is basically just one character, just one string. Looking at it that way, just like one string like this. That is what and a character is. So if I say something like we have A, B, C, and D like this, just this is one character, right? It's not a combination of all of them. This is a character. This is another character. This is another character. So a combination of all of this is a string. An array of this, an array of A, B, C like this is a string. But when you define string, you don't usually use this square bracket, right? But that's what the computer interprets it to. That is what the compiler interprets your string as. So, and that means that a string is a collection of characters. So by talking about strings, we need to talk about characters, and this is the character. But when we talk about string now, a string simply means something like this, right? So if I have a string, let's say I have a string called ABC like this, what that means is that it's a collection of what? Characters. That's basically what it means. So, but you can see the difference between what I'm doing here and what I did here. A character, excuse me, in Rust takes in or uses the single quote. A character in Rust uses the single quote, while a string uses the double quote. So in this case, if I have something like this, a single quote, that's a character. Whenever you see this in Rust, it basically means it's a character. So let me define something like this. This is valid, like totally valid. But if I use a double quote, it's going to flag it. That's what it means. So if you try this now, see that it's telling me that it's a mismatched type. It's expecting a character type, but it found a type of string, right? So it's giving you how to fix it. If you want to write a car literal, use single quotes. This and that way Rust helps you, right? Like I said, it gives you good error messages. So what it's telling me now is that you use single quotes, like I have here. So now this is a character, but this is a string. So this is a string, ampersand str like this, because I can do this. So this is a string. This is a character with a single quote, a string with double quotes, right? That is it. So now we have a character here, we have a string. So that's basically the difference between the character and the string data type. There are a lot of more information to it, but I think this is just the basic and the simple way to just see it. The character type in Rust is just one character, one particular character, one. And then you can have a string as a collection or a list of characters. So if I write it like this, the way it's going to interpret it is what? A collection or an array of what? Of the characters. So it's going to interpret it like this. So this is what it interprets it as eventually. So, and that is one of the reasons why we see that there is this ampersand here. Ampersand just means reference. We are making a reference to something, but we'll talk about that eventually. Let's not move on. Let's not go to that for now. So yeah, so that's basically that's about the string data type and the simple data type, right? Now let's talk about the variables now. Right, let's just make mention. Let's talk about variables and what they are before we move into the other complex data type. Let's just follow these examples. So we have the variables now, right? What are variables? So in variables, variables as in Rust are just similar to other variables in other programming languages, whereby you have let me give you a space between this so it can be clear what we are working with. So let's talk about variables, right? So variables in Rust is just like you have in other programming languages, or even if you're not familiar with other languages, what it means is that you use a variable to store a value. So let's say, for instance, I want to store my name, just like I've done here. I'm using this alpha is a variable here. I'm using it to store a character called this. So this is the value. In this case, I'm using this variable name. This is the variable name, and this is the type of the variable, and this is the value of the variable. So when I declare variables, I need to use the let keyword, or I can use the const keyword. But let's not talk about const for now. Let is the most popular type you use, right? When we use the const, when we come to the const, we'll talk about it. I'll see how to use it. But for the let type, we use let to declare our variables. Now, if I have a variable called name, for instance, it means that I want to declare my name like this. And I'm simply saying that let name equal to my name, Mayowa. And it means that this Mayowa now, this name, whenever it's being used, means this value. So that's what a variable is. Use it to store a value, basically. So that's the idea. But then the type of the variable is what? A string data type. So to write a string data type, we use this ampersand keyword character, and then the string to also in front of the ampersand to say that this is a reference to a string type and stuff like that. Don't worry, we'll talk about the ampersand thing eventually. So after talking about okay, so now this is what a variable is, right? That's what we need to know, like in a simple form of what a variable is. So, but don't forget that you can tend to infer, you can tend to add this like this and it still work, or you can remove it. So one way the compiler works also, let me just specify this. So let me comment all of this out since I'm not using them. So I won't get the error of unused variables. So if I have a variable like this, let's name equal to, and then I print name. Okay, so if I print the name, okay, so if I print the name like this, let's say I use this. This is a name. This is my name. And I do something like this. Yep. Yes, you don't always have to declare type. That's the point. So what I'm trying to say is that the compiler can infer the name. So I'm trying to show you what will happen if I don't use this, if I don't infer the type. So let's say I don't want the type like this, right? It will still work. Now, the reason is because the compiler will infer the type for you. That means the compiler will make assumptions based on what you use. So the compiler will say double quotes, it'll be like, okay, this is actually going to be a string. So that means that it's going to be a string. So the compiler can make assumptions too. So now if I print this, it's still going to be valid, right? I'm still going to get my name is this, even though I did not add the type to it, right? It's still valid. But the only time it goes wrong is if I add the type and then I specify a wrong value type, then it's going to flag it. But if I don't specify it, right, it's going to accept it. If I define another one, let's say number A, and I just say 7, for instance, without specifying whether it's a U8 or a U32, right, or a U whatever, it's just going to assume a value for it. So on the compiler, we assume that, okay, is this, and say, so if I print this, I'm still going to get the actual thing, right? And you can see I still get 7 here. But the compiler is giving me a warning. What's that warning now? And the warning is that convert the identifier to snake case. So that is another, this is just a convention in Rust. Snake case type. So if I run this again, the warning is going to disappear. And then you can see that I still have the 7 here. Now the 7, it doesn't mean that it won't work, right? Whether I infer the type, whether I specify the type or not, the compiler can make inference through the data type that I'm using based on the value. It can assume that, okay, that means since you are specifying this, this is what you want to have, or this is what you intend to have inside of it, and it will work fine, right? So now it's just important to know that the computer can also make inference for you based on the value that you specify to a variable. So that's just important to point out. So now let's talk about a bit about print statements, right? So before moving on, let me talk about this print that I've been talking about. So, but before that, just any question, please, about the whole thing, everything we've talked about, the entire thing we've spoken about since. Any question? I assume no questions. All right. So that is that for variables. Now, looking at this now, I've been talking about print line since. Any question or a message? The default type for an integer, I think Rust uses the U32 as a default type for integer. Right, so it uses the U32 as default type. So that's why, as much as possible, U32 is very large because it assumes that because of that, any type you use, any integer rather that you specify, it should not go beyond that range. But that can lead to using extra memory size to memory space, because let's say I want to store like 7. Why do I need to use U32? Right? Why not just use U8, which takes 255, and that just works for me. So the default type is, I believe, is U32. If I assign it to a negative value, it's not going to work. Remember, I said that. Oh, you mean like this, without specifying the type? Yeah, it's still going to work. Like I said, the computer will make inference. So let me just print it down so you see. You see that it's still going to work because in this case, I didn't specify the type. So the compiler knows that it's just going to make inference based on the type. So if the compiler sees the negative, it will just automatically assign an integer type, not an unsigned integer type to it. So that same way, it can still print that. Is that clear, please? Okay, so that is just the idea. That's basically everything about the variable types, right? And there are other things too. For variables, you should be able to variables in Rust are not mutable by default. So two things to know about variables is that they are not mutable by default. In the sense that if you want to change them, right? If you want to change the values of variables, you need to explicitly indicate that. So that means if I want to change this value, say I want to, in this case, now in other languages, we allow you to do something like, let me give an instance. I can say, let's say JavaScript, for instance. You can do something like this. It's totally valid in most languages where I have, let's say I have my name equal to, and then I change the name. Maybe after some time, I write some, I have some other code here, blah, 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 blah. And then I change the name here to blessed like this. It's possible in JavaScript. If I do something like this, right? No, not const. If I use let rather in JavaScript, I can do this. But if I use const, I can't change the name. Now, like I said the other time, we have const in Rust too, right? Because it borrows every from different languages. We have const in Rust, which does the same thing, the same way JavaScript does it. I'm coming to that. So let's say we have let like this. Let name equal to my name like this. It simply means that this name, I can reassign it to this. But in Rust, I can't do that. I can only do it if I tell the compiler that allow this to be changed, adding a mutable word to it. So now if I want to do something like this now, I have to add this mutable keyword. And then I can now reassign the value like this. But if I try to reassign the value like this, without doing this, it's going to flag it. It's going to give me an error. So let's try it out and see. So it means that variables are not permitted to be reinitialized without explicitly saying that they can be initialized. So do you see it now? Cannot assign twice to immutable variable name. So it means that all variables in Rust are immutable by default. Like I said, they are immutable by default. And if you want to change the variables, you need to explicitly indicate that. So now let's see the execution again. It says what? You cannot assign twice to immutable variable name. So and you see that the program does not give any output. It will fail because that's a complete error. And then how does it tell you to fix it? It says consider making this binding mutable. That's what it's saying now. So add a mute to it. You get. So it's already telling us how to fix it. So now that is one way Rust is just helpful in many ways too, but it's just one way it is helpful. So in this case, now if I add a mute to it, just like Rust asked me to do from here, right? It says I should add a mute to it, and it's telling me where to add it. So if I add a mute to it now like this, and I run this code again, you can see that now I get no error, right? Even though there's a warning about the variable name, right? And what is the warning? You say it is maybe it is overwritten before it is being read, right? Now it's telling me that the value assigned to name is never read. That's this name. So we'll come to why this is happening eventually, because you can see that even though I'm using this name here, it's still complaining that the value of name here is never read, right? So yes, All right, so now let's proceed from there. So now that's just what is happening there. So we have this mutable keyword that allows us to change the variable or the value of a variable, right? So the first value we had was this, and then because we added the mute keyword to it, we're able to change the value from this to this. So that's the first thing. There's another concept in Rust. Let me just point that out, which is called shadowing, right? In variables. Let me see if they pointed that out here, so we can use that. Okay, it's not. Shadowing. Let's consider that. Yep. Question. Yeah, please go ahead with your question. So, yeah, question, please. Question. Shadowing. Yeah, this is shadowing. So let's talk about shadowing because it's still relating to variables, right? Any question, please? No question. No message. All right. So now let's talk about yeah, Jude, you have a question. Okay, Obalua. Okay, it was a mistake. Yeah, I didn't hear you. Can you drop it as a message here so you can just treat the question? Okay, in case I missed it, you said they are const and variables declared with let immutable. Yes. So the reason for const, that's why I've not talked about it. Const is a very special case, right? And it works similar to how it works in languages like JavaScript. JavaScript is like one of the older languages that uses const very well. So that's a perfect way to give comparison. Now, for const in Rust, const in Rust is let me just give you an example so you see. So let's say I have something like this. I have to specify it at the top level of my code though. So if let me say I specify const like this, right? 158 or something. Let's say this is const, right? Now, in this case, the reason why we can use const is because you can never reassign the value of this const. But you see this let, even if I don't specify mutable like this, right? I can still do this and it will work. I don't know if you get. Let's try this out. So you see what I'm saying. Where's item? Let's complain about. Okay, missing type. Okay. Missing type. So I need to specify the type for this. No. I can't use U38. Let me just comment this out first. We've not gotten to that data type, so let me leave it out first. Then talk about this. Now you can see that it still worked. I didn't get any error, right? Even though I'm using the same variable name twice, like this. So to answer your question, in this, if I define this const like this, let's say I define the const like this. Let's say I use U8 and I say, let me just say default age equals to 7 or 12, right? This is valid. Now, this is const. I can never reassign this const, but I can reassign the value of name using let. Now you can see that this and this is almost the same. Let me move this up here so you can see it clearly, or the comparison as clear as possible. This is valid in Rust, right? Like it's very valid, and you can see from the execution that we have that it still worked. So now, why are we not using const for this? You cannot use const within. There are rules to const, and let me show you some of the rules. I think it's easier for me to just show you. Where can I see that? Let me go to Rust book. I think it's clearly defined in the Rust book much more. Where is the Rust book? Okay, Let me just go to the rules. The rules to defining that, like the rules that govern the const and lets. I want to show you the rules that govern them. So, but first of all, like I said, you have to have it at the top level like this, right? That's the first thing. So let me show you. Where's that? Variables and mutability. Okay. So constant, yes. So now look at this now. Like immutable variables, right? Constants are values that are bound to a name and are not allowed to change. But there are a few differences between constant and variables. First, you are not allowed to use mute with constants. That means you can never mutate a constant, right? But a let, like this, you're able to mutate it like this. Or you're able to reassign it like this by reinitializing it with a new variable. Now, constants, okay, where did I stop? Okay, you declare const using the const keyword, like we have done here, you can see. And instead of the let keyword, and the type of the value must be annotated. So that means when you define your constant also, you must always specify the type. No, in let too, you can decide not to, like I said, the compiler can infer the type in let. But for const, it has to be specified like this. It always have to be specified. I don't know if that makes sense. So now we'll cover type, annotations, stuff. Constants declared in any scope, right, including the global scope, which makes them useful for values that need many part of code needs to, like, that many part of the code need to know about. Now, the last difference, constant may be set only to a constant what expression, not the result of a value that could be computed at runtime. So, yes, question. Okay, by Francis. Okay, so now based on what I'm explaining here now, the last difference is that constants can only or may be set only to constant expression. May only be set to a constant expression, not the result of a value. So these are like the rules, like you can see now. So there are rules to all of these things. So the first one, like I said, is that you cannot mutate them, right? Impossible for you to mutate it. So constants aren't just immutable by default, they are always immutable. They are always immutable. They can be declared in any scope, including the global scope, which make them useful for values that many parts of the code need to know about. And the last difference is that constant may be set only to a constant expression, not the result of a value. I don't know if that makes sense. So now, but if you look at the difference between them, this is the shadowing I wanted to talk about. We'll come back to that too. But to answer your question now, the reason why we use the const, right, is that we want to just declare something that is going to exist for the lifetime of that code. Now, in this case, now if I have a default age like this is a perfect example. I don't want the age to ever change. I want the age to forever remain the value it is set to. Right? And that is just it. So whatever I set it to is what it is, and it must just remain that value. That's what we are trying to work on. So now you can see that this is just all clear. So that is basically what we have. So for the const now, I don't know if this answers your question about Lua, right? The const, you use it to declare values like this. Let's say you have a value, a variable that you don't want to ever change. You want to use like a default, like this now, like default age now, so that you can use across your entire program, right? You can define it with const like this because it will never change. Throughout the entire lifetime of that program, it will never change. It will just remain like that. But for the let, you can always modify it. There are ways to modify it. Imagine if I use let here, I can always specify let again and say somewhere within my code, I can say 7. And then I'll start seeing that this is a bug. I specify it as 12 here. Why is it not working again? Because I've already changed it. But I will not imagine it is a large code base. I will never know I've changed it. So for things that you want to have like defaults or you want to have like a defined or predefined value for, it's best to use a constant for it. So that's the major difference, right? So now for the lets, like I said, we can reinitialize the lets with the same name multiple times. So I can do it again multiple times and specify another name to it like this. It's still valid. But the difference is that this will be the last value it's going to always have. Now, in this case now, the name is going to be this, it's going to be this, but most importantly, is going to be now this that will be returned at this point. So that means the name will first become Mayowa, then to change to blessed, then the last value will now be new name, and that's what will be here. So, but that is just what let allows you to do. But if I don't want to use the let keyword like this, I have to specify the mute keyword here, meaning that I want to mutate this particular variable. Now, what this means is that it's going to create 3 slots in memory for me. This name is a different, is taking its own memory space. This is taking its own memory space. This is taking its own memory space. That's the danger of using something like this. And that is why if I run this function, let me run this code now, you will see that it's going to complain about name for me. It's telling me that there's an unused variable name, even though I'm using the variable name here, but it's still complaining that I have an unused variable name. The reason for that is because this name is a variable that is being used, that is allocated space in memory. This is another one that is allocated space. This is another one that is allocated space because I'm using the let 3 times. So it means I'm initializing these 3 different variables. These are 3 different variables, right? They are not together, they are not interfering with each other. But if I do this like this, it means I am changing this particular name value in memory. But if I don't use this and I use the former one, it means I'm creating new variables and new variables. So that is why I keep having this unused variable name here. I don't know if it makes sense to anybody. You can see that it's complaining twice. It's complaining of the first name. The first name is what? Mayowa is not used. The second name is complaining about is what? Blessed is not used. I don't know if that makes sense to you guys. So you can see that it's complaining about the 2 variable names that I declared before this last one called new name. So it's important to know that when you do something like this, you are at the risk of leaving the variable unused like this. It's a different variable. It's not reassigning it. If you want to reassign it, what you need to do is remove the let keyword and use the mute keyword. That way, you are simply saying that change the value from Mayowa to use blessed. And you're saying again, change the value from this blessed to using new name. So that's what happens within the entire this variable here. So now let's talk about, I don't know, is this clear enough? Is this clear to everybody? Is there any other question regarding this variable type that I need to talk about? All right, so I assume there is nothing. So now let's talk about I think that'll be the last thing for today's class. Let's talk about the scope, right? Let's talk about shadowing, like I mentioned. Now, okay, you can see that you can declare a new variable with the same name as the previous variable, right? We can say that way, we say that the first variable is shadowed by the second variable, which means the second variable is what the compiler will see when you use the name of that variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is shadowed or the scope ends. Now, looking at it this way, what we did here, just at this point, the other time, using the let is that we are shadowing this name. It simply means I have a name defined. So let's say the name is in memory like this. I have a name. Let's say this is the memory. Let me try to see if I can draw something for you guys. Let's say I have this in memory. Okay, let's leave that for now. Let me see if I can. Okay, so let's say I have this in memory. Let me just try to see if I can draw this and say, let's say this is a memory space, right? And the memory space has like lines. Let's say this is a memory space. This is another memory space. Right. So going back to what we are talking about here. So let's say this is name. Let's say this is name here, right? This is name here. The name in this case equal to what? It has a value of, the first value I define for it is what? Mayowa. So in this case now, because I define Mayowa for it, it's going to have a value of like this. This is what it is, Abby. And now, this one is what this is. If I shadow this name, like using this now. This is called shadowing, like I said. Everything we've done so far, I've explained. This is the shadowing part. So if I shadow this now and I create this again, another variable, and I assign another value to it, I'm shadowing this variable. So that means this is his own variable. This is also his own variable. Very different from each other. They are not using the same. This is the memory space, right? This is a memory space. This and that memory allocated to name. So there are two memory available in memory. In this, there are two names rather available in memory in this case. But if I reinitialize it by doing this, by adding the mute keyword like this, excuse me, by adding the mute keyword and I remove name like this. What I'm simply doing here is that I am reassigning this now. This is no longer name. This no longer exists here. The moment I put this now, I'm simply saying that remove this and replace it with what? A new value, which is. So that means this one is going to be removed totally. This one is going to replace it. So this one is going to be removed. Let me scratch this or strike it through. So I'm going to strike this with whatever. Let me just say this one is no longer going to exist. So it's going to be removed. So then this is the new value. I don't know if that makes sense. So that's basically what the shadowing means. Shadowing, you still have the same value in memory, but for just reinitializing the variable, you are simply changing the value in memory. But when you shadow, you have the same value in memory, like the same variable, different variables in memory, which is not the best for this use case. But the time shadowing comes to play, and that makes sense, is when we are dealing with scopes. Now let's talk about that using an example. So when we have scopes like this, in this case now, let's say we have this kind of example, right, whereby we have scopes. Now what do we mean by scopes, first of all? Let's talk about that. So if I have a scope, it simply means that this, okay, let me give an example of a scope. This is, let's have a function, first of all. Now this function in this case this is a scope, right? This is a scope for this function. So that means if I have something like let u equals to 5, and I say I have a scope like this is totally valid in Rust. Like it's valid in Rust. You can have something like this. The reason why you can have something like this is because the curly brackets that you have in your function, when you have a curly bracket in your function, is a scope. We call them scope because, like for instance, now you can have a global scope and a local scope. That means whatever you define outside of functions is global. That means every function that is below it and make use of it. And when you have a scope also like this, when you have a curly bracket, basically just understand that when you have a curly bracket, you are defining a new scope. That's the idea. So you can do that for loops, you can do that for anything. But once you have a curly bracket like this in Rust, you are defining a scope. So that means you can have a scope like this. This is a scope. You can also have a scope that is defined inside that scope. And inside that scope, you can now use that shadowing the way you want to use it. Right? So then I can now do something like this. And then if I print this place now, if I print this function, this scope example, what do you guys think I will have? By the time I print this, using the example given about the scope the other time, and we have explained it from the diagram. So what do you think I'm going to have here? So if I run this scope example, this is the first thing that will be printed. What will the value here be? And what will the value here be? Anybody can try, just try. So we can know that we have been following what I've been talking about since.
I think this is the 6. The first one is the 6 and the second one is the 5.
The 5, yeah, actually. So that's very correct. So we have that, and we have something like this. So if I just do this inside my main function, remember the main function is my entry point to my code, right? So if I run this now, simply because all of those stuff. Now you can see that the first value, the new value is what? 6, just like Michael said. The reason is because even though we are shadowing this variable, right? We are using this within a scope. And when you use something like this within a scope, what that means is that whatever you do within the scope is gone. Just like you having a function. You having a function like anything that you have inside this add like this. You know that I can't use it inside another function. Like for instance, now I can't use this num1 inside of this place. I can't use num1 here. It's an error. I can't do right. Same way I can't call it can only be used inside here. That's if I'm defining the variable inside of this scope. It can only be used within that scope, not outside of the scope. So, but then I can use this value here, right, inside here too. So let's say I can still use this here. I can use, okay, question. Oh, you can't see my screen. Oh, shit. Maybe it's your network. So can any other person not see my screen? Who else cannot see my screen, please? Okay, so try to join again, right? I'm sure it's network. Okay, all right. So what I was trying to say is that you can define a function outside of a scope, a variable rather outside of a scope, and use it within a scope. But whatever variable you define within a scope cannot only exist within the lifetime of that scope, right? So let me add this comment here. Whatever variable you define within a scope only exists within the lifetime of that scope. Now, what do you mean by the lifetime of that scope? This is the beginning of the scope. This is the end of the scope. Once you come out of this closing bracket, this variable becomes deleted. Remember we talked about memory management, efficient memory management in Rust. This is one of the ways it does it. That means you can have a sandbox. You can have a sandbox scope within a function. So that means I can have a complete logic that does something different within this function. And it will do that very much. Right? I can have like 20 lines of code within a scope like this. And then when I'm done, right, I can use it to process something entirely different and then come out of, sorry, excuse me. And then I can come out of this. Sorry, excuse me, guys. So I can have that. Okay, so yes, so I can have this as it is here now, using this test value here like this, from coming from outside here. For if I have this here, because it is within this scope, I can have this as its opening scope and this as the closing. And what this means is that whatever is inside here that I define within this scope is used within the scope alone. I can execute a lot of code within this place, but it doesn't tamper with what is outside, except I'm assigning the value to a variable that is outside. So another way we can try that is if I have this as mute, right, and I say like this, right? And now let's try to print the value of test value. And I say test value like this. Now, if I print this and check it out, what do I have? Rust has no post-phrase increment. Oh, sorry. So let's say you have something like this. Value plus 1. Let's do this, like, and then we debug this. Now, you can see what I have here. The first value I have is what? The new value of 6 and 4. And 4 from here is what? 4 is this test value here, right? So that is the 4 thing I see here. But I now increment the value from here. And then that means I'm incrementing, since I mark it as mute here, right? So that means I can increment the value of this test value. And then I can add 1 to it. And once I add 1 to it, this becomes 5. And if I print it outside of this scope, remember this is the scope, right? If I print it outside of this scope, I can still get the new value. Why? Because I've been able to add this mutable keyword to this value. Now you can see where everything comes together now. Everything we've talked about, the mutable, the scope, the functions, the variables, all of those things. Now you can see where they come together here, right? So that's the idea. So now, any question regarding this, please? The scope, the variable, the shadowing, all of these things. We use shadowing, we use scope, we use variables, we use mutable. Everything we've talked about here today. Any question, please? Okay, so no question. Assume everybody gets it. That's cool. That's nice. That's nice. I'm happy that everybody understands what is happening here. But the idea is, since I'm going to be wrapping up the class now, I have another meeting to jump on. So sorry. So, but the point is, we've already talked about almost everything that I planned for today, and I'm happy that everybody got it right. So, yes, please. What our advice is, just try to go back and play with all of those things. It's easy for you to understand now, but forget even before the end of today. That's one thing, because especially when you're learning anything new, these things happen. But the idea is, if you still try picking up this, just play around with it, especially if you are starting with Rust or any programming language. This is a lot. I know it's a lot, but trust me, it's very simple. Everything we've talked about for the past almost 2 hours now is just how many lines of code. If I calculate everything, I'm not sure it's up to 20 lines of code. If I remove all the comments, right? So that means it's something you can go over and practice yourself, and you can complete it in less than 15 minutes to go over it again and try it yourself. If you are reading it, you can do it in less than 2 minutes. If you are practicing it, you can do it in less than 10 minutes. So the idea is, go back to try this thing out. Just go ahead, try it out, see the results. It's not too difficult. Rust is not difficult. It just has a lot of rules that you must follow. And that's why you see that I keep mentioning that there's a lot of rules. And then I try as much as possible to show you where possible, even from the Rust book itself, right? So it's very important to have those rules in mind. And because when you know that, oh, this is not allowed in Rust, you can easily switch from, okay, this is how I write my code before. This is how I write it now. Like you can see me making the mistake writing test val plus just now, because JavaScript and other languages, Solidity allows me to do it, but Rust does not allow me to do it here. So now it just takes a bit of shifting your scope when you think about Rust. So when you write any Rust code, you need to rethink the way you write code, because it makes you write better code. That's the truth. But it takes a lot of consistency to understand it. You need to practice, you need to know the rules, the syntax. So everything we've done today is just understanding syntax. You can't do this. Like for string, for instance, now you know that you can't define your characters using the double quotes. You have to use a single quote. So all of those things, they have those things in other languages to write, but C++ to has the same syntax. But the idea is that when you write low-level languages like this, they help you understand the high-level languages better. Right? And if you are starting with a low-level language like this, it makes you write better code from the beginning. So what simple thing I'm trying to say, and the advice I'm giving you guys, is try to play around with this. You can pick up any example. You can use this resource that I've been using. I use a lot of resources, not one. It's anyone that I feel like explains it better. So I have the Rust book. I have this Rust lab. I have the Rust exercise. I have the a lot of them. Even this Google's Rust exercises, to have a lot of them that you use. The reason is because the exercises, so you can pick it up around with the simple, simple things like integers, assigning these, declaring your variables, changing your variables. As simple as that may be, is actually your path to understanding Rust and to being a Rust developer at the end of the day. Because everybody that writes programs starts somewhere. Myself, I started somewhere. But now I can understand when I see this code and say, okay, this is what should be done. This is what I need to use. So it takes understanding the data types you need to use, the syntax, and then the logic comes last. The syntax first, the rules, right? Then the logic comes. So you need to understand those things. So right now we are dealing with syntax, making it familiar with you. Like you need to be familiar with every single thing we have. What is let? You know it. What is the fn keyword? You know it. Why do we have main? You know it's the entry point. Why do we have something like this and it works? It's because we are sharing this. Like, why is that variable? You understand that now based on the explanation of the diagram, because I'm assigning different space in memory before, but now I can reinitialize the space in memory. You understand all of those things, right? So all of those things are just a way to make it stick, because it needs to stick to you. That's the idea. If it doesn't, then it's pointless. So that's just an advice I can give to you guys. Then you understand scope now. That whenever you have this curly bracket, it's not only in Rust this is used, but I think Solidity has those too, which works too. And you have scopes, and then it works well. So please try to use this the best of your ability. Try to go through it again. Make sure you understand it. That way it makes it familiar. You just need to be familiar with the syntax first. And once you do that, every other thing works. So yeah, that will be all for today's class. So the class is going to continue next week, right? It's going to be every Mondays from 8 to 10. The same link. So if you're interested, you can share it with others to join. If you have anybody that is interested in learning, I will share the video for this also. I'm going to share it on Twitter, so please you can watch out for that. And yeah, just watch out for it. Or if you follow me already, you will see it on my timeline. You can always come back to check today. Once I get the video back, and I edit, add some other things, remove the first part that was talking about something else, but I'll still post it on my Twitter today just to have access to it. So you can always go back to watch it if you are not clear. And if you have questions, please don't hesitate to drop me questions. You can DM me on Twitter or my WhatsApp. I'll drop that also. You can message me today. If you have questions, basically just DM me on Twitter. I'll respond. Right. So yeah, that'll be all we'll talk about today, right? And we'll continue from here next week. We'll start with conditional statements next week, and just continue to move like that. So we'll keep taking it step by step, building upon previous knowledge until we are familiar. Then we start taking exercises, right? We start doing things practically on the core. Start building certain things. You want to build this. How does it work? Make mistakes together, learn together, fix it together, see how to fix it together by going to Stack Overflow using AI, different methods. So all of those things is going to be fun, because I'm also not an expert at it, even though I know a bit about it. But we learn together. That's the idea. So that's why it's a live call. You can ask questions. So yeah, that'll be all for today. Thank you guys so much for joining. Thank you everyone for joining. Okay. Yes, questions. Anolua, then Samuel.
Oh, sorry, the hand was a mistake.
Okay, all right. Samuel, you have a question.
Good morning.
Yeah, good morning.
Yeah. So I just saw the meeting link later, and I decided to join. I'm wondering, is it possible that I think it's being said the classes is always going to be 8 to 10 a.m. on Mondays. I don't know if I'm right.
Yes.
I was wondering if it's possible, like you can create a calendar. How do they do this? A calendar meeting link, like one can add to their calendar. It's
okay.
like kind of like reminds you every year.
All right, I'll try to implement that, and I'll share it so that if you but then the only way I can do that is by sending you a mail, then you add it to your own calendar.
Yeah, if it's also possible, we can like drop a mail. I just feel it might be helpful,
Yeah, sure. I think what I would do is I'll drop a link whereby anybody that's interested can get a mail. Right. I'll send you the mail, add it to your calendar.
All right. Thank you.
You can follow my account if you need like updates of this, because I'll drop the link to this recording today. Also drop or better still, just watch out for this whole information on my Twitter page.
Yeah, to follow you on Twitter, though.
All right, thanks. I'll do that. I'll do that. Thank you for the suggestion. All right, so that'll be all, guys. Jump off now. Thank you so much for joining once again. See you guys next week. Please and please, if you have questions, don't hesitate to drop it. DM me on Twitter. No issues. Just DM me. I'll reply and ask your questions. Thank you so much. All right now. Enjoy the rest of your day and the rest of your week. Bye, guys. Yeah.